So last time we talked, we did letter A, which is this exact same type of problem. Letter B and letter C are the exact same process. I just want us to keep practicing it because I'm sure we didn't do this type of problem in our like long weekend since we've seen each other, right? So we have this formula down, y equals c over 1 plus a times b raised to the x. And remember, c is our limit to growth. So I'm going to go look at my new problem. My initial value, as tempting as that is to make that a, it is not a. My initial value is not a, okay? It helps us find a, but it's not a. Remember that we want to write that as an ordered pair. The ordered pair is 0, 16, and then we can use that as an x and a y. Okay, and then my limit to growth is at c, and then we'll use that other point again in a second, okay? So we're going to set up that equation using the original c that we have, and then the first x, y point that we have as well. And then we're going to go from there. So give me 1 second to do that. Yeah, that's all right. So I have 16 is equal to c, which is at 128 over 1 plus a times b raised to the x, which is 0. Is everyone okay on how I'm setting up to begin with? Okay. We're going to cancel that b to the 0 because what is anything raised to the 0 power? 1. Good. So that cancels out. So I'm left with just 16 equals 128 over 1 plus a. Now I want to cross multiply, or some of you just think about let's multiply by that 1 plus a on both sides. It doesn't matter how you think of it, cross multiplication or multiplying by the denominator does the same thing. We just don't want any fractions, okay? So I'm going to multiply by 1 plus a to both sides, and I get 16 times 1 is 16, and then 16 times a is 16a. And that's equal to 128. Because those cancel, and I distributed that. Okay. Now I have a pretty simple algebra 1 problem where I'm going to minus 16 from both sides. And then I'm going to divide by 16 on both sides. And I believe that's 7. Somebody double check that for me. Does that look good? Okay, perfect. Now I have my A. My C is over here. I'm going to reuse that C. And then I'm going to use this new point that I haven't even looked at yet, okay? I had to get my A before I could even consider this point. So just like the exponential problem we did on our homework, you have to do this in 2 parts. Always do the point with 0 first, then do the point with both numbers second. Okay, so I'm going to set this one up. It's going to be 32 is equal to 128 over, and it's going to be 1 plus that A was 7. We just found that times B to the, in this case, it's to the 5th. Anyone confused on how I set this next equation up? Okay. So now I'm going to solve, and I'm going to immediately have to do my, yes, Chase.
Why was it a 0 the first time?
Good. Because it's the initial value, and the initial value is when x equals 0. That's when it starts. And then this one is a ordered pair that has 5 first. So that's my x value. Good question. Any other questions? Okay. I cannot do any simplifying. As tempting as it might be for you to do 1 plus 7, you cannot do that because 7 has the b raised to the 5th attached to it. So instead, I'm going to either again cross multiply or multiply by 1 plus 7 times b to the 5th to both sides. That is a way too big a reason. Okay. And this one, I think it's just as easy to do cross multiplication. It's the same math as what we did before. When you do this, remember that we are doing 32 times 1 plus 7b to the 5th, and then 1 times 128, which that 128 just stays as 128. I have to distribute that 32 to both the 1 and the 7b to the 5th. So I get 32 plus, well, I'm going to have to pull my calculator out. I'm not doing mental math like that right now. 32 times 7 is 224, b to the 5th equals 128. Am I moving too fast? Is everybody with me? Okay, minus 32 from both sides. And I get 224 b to the 5th equals 128 minus 32 equals 96. When I divide by this 224 from both sides, again, as tempting as it is to make it a decimal, I'm gonna push us to keep it as a fraction, okay? So 96 and 224, I'm sure have a common factor. I'm sure they're both divisible by 4, right? 96 divisible by 4 is 24. 224 divided by 4 is 56. Are both of those divisible by 8? Okay, yeah, that's 7, and then that's 3. Okay, perfect. So again, as easy as it would be to make it a decimal, I'd rather be a fraction, okay? Because I'm gonna leave it as a radical in the most simplified form I can think of, okay? So this says b to the 5th is going to be equal to 3 over 7. Again, I would prefer this not to be a fraction, so when we start to solve and we fifth root both sides in order to get rid of b to the 5th, that's actually simple because I'm just gonna leave it as 3/7 under that 5th root. I want b equals the 5th root of 3 over 7. That's my b. Now, if you had put in the calculator, did we go over how to do a 5th root in the calculator? Okay, if you don't remember, it's that math button and then it's number 5. And most of us can type in a number right there. So I'm gonna do 5th root and then you can do 3 divided by 7. So I can get that decimal. Some of you have a little bit older calculator, so it might not look exactly like that. And I'm willing to help you as we go. So you might have to type the 5 in first and then do math. So you might have to play around with it so that you get it correct. But I don't even need it like that. I want it like this as a radical. So I'm gonna stop everything. I'm gonna put everything into my equation. So I'm gonna use my, why is it keep doing this? Why is it like my iPad has like a dead zone? Does that happen on your guys's? Cause like, when I have it like this, sometimes I can't touch that pencil button again. Is this a me problem or is this an iPad problem? It's my iPad. Thank you so much. That's the nicest thing you've ever said to me. Nothing makes me more frustrated than when this doesn't work right. Okay, y equals 128 over 1 plus 7 times the 5th root of 3/7 raised to the x. All right, we got another problem like this, and I actually want you to try it on your own. Now, it's gonna look a little different than these are set up. So when you're done with this problem, flip over to letter C and see if you can identify what is the initial value, what's my limit to growth, what's my other point. Because I gave you the exact same information, but in a slightly different form. Okay, as we flip our paper over, who can tell me what my initial point is tonight? 0, 5, good. So that's gonna be the first XY that we use, okay? What's my limit to growth? Because that was usually the next thing I used. What's my limit to growth? 20. Good, remember that limit to growth is that numerator, and we talked about that being my horizontal asymptote. So we're gonna start by using 0, 5, and 20. And then once we find A with that, then we'll go back and do the 210 point. Okay, I'm gonna be quiet for a second. I want you to try it and I'll put my work on the board. Okay, I've got my first part on the board. Anybody have any questions on getting letter A? Once you find letter A, use that other point that we haven't used yet, 210, this A, and then your limit to growth, and we'll find B. Off B and A, but you can always come and take your test regardless. Which period you want to come to? Yeah, that works. I've got how I found A on the board, and I have how I found B on the board. And I'll put it all together now. Okay. There's that. Anybody have any questions on that? Any questions? When you're finished with this one, we are gonna go back and we haven't done 1 and 2 yet, so go ahead and flip back to the beginning of section 3.2. I know I'm skipping around a lot and I'm sorry, but we're gonna go back to the beginning there and then we'll be ready for some more problems. Hopefully we'll get at least 1 or 2 done before class is over. All right, so when we go back to the beginning of this section, we're just doing a little bit more talk on growth and decay, initial value, percentage of growth, decay, all that fun stuff, okay? So we have been doing this basic formula before with our exponential. Let's see, it doesn't say the word exponential, but these are, again, our exponential functions. And that uses the formula y equals a times b raised to the x. Do you guys remember doing that before? It's on our homework a minute ago. Now, from here, there are some important pieces, okay? Which piece of this do you think is my initial value? Is it A or B? A, good. So by just looking at my equation, we know that A is my initial value. So I can go look at these 2 examples. We'll come back and do the growth and decay in a second. But what's my initial value for letter A? 5,607, right? I'm just gonna call it IV just because I don't want to write out initial value. So 5,607 is my initial value for the first one. Easy, just identifying that first part. And then what about for letter B? What's my initial value here?
3.7.
3.75, good. So that's my initial value. The growth and decay and the percentage of growth and decay come from letter B, the other letter that we haven't touched yet. So this is my growth and decay. In a little bit, we'll talk about that just being like the rate of change. But as of right now, we can look at letter B to find our growth and decay. Okay. Now, if it is less than 1, it is decay. If it's greater than 1, then it is growth. Okay, so what is this first one? Decay, right? So it's decay. And to find out how much we're decaying by, we can do 1 minus that number. So 1 minus 0.963. Because think about 1 as being 100%, and then 0.963 is 96%. So we're just finding the percent that we're changing, okay? So we're going to minus those two numbers, and I end up getting 0.037. And the only last step I want to do is make that from a decimal into a percentage. So move that decimal place 2 places, bump, bump, and that becomes 3.7%. So 3.7% of decay is what we get in this problem. Okay. Similarly for the next one, except this one is not an example of decay, it's the opposite. And I know that because it's bigger than 1. So that's an example of growth. This time to find out what my growth is, we can do this number minus 1. Because it's the bigger number. I'm just trying to keep positive numbers here. So I'm going to do 1.072 minus 1 minus that 100%. And we can actually do that in our head, 0.072. One more step, move those decimal places, 1, 2, and we get 7.2% growth. It's pretty self-explanatory, right? Okay. We're going to keep moving on with this, but I'm going to teach you another little formula that's going to make more sense as we do word problems. So go ahead and flip your paper. We're going to go to number 2. It says write the exponential function, okay? I know that I'm giving you a lot of formulas today / this unit, but we can handle it. The exponential function we just were doing was y equals a times b raised to the x, and I'm just going to keep doing that just so that it's in our head as we go. The one that I'm going to teach you right now is very similar, but it's more helpful when we're thinking in word problems. We're going to say P of t equals P sub 0 times 1 plus r raised to the t. P of t equals P sub 0 times 1 plus r raised to the t. And I actually stacked them on top of each other for this, for you to see the similarities. We just said that a was our initial value. So what's my initial value in this new equation? That P sub 0, right? That sub 0 just means my P at x equals 0. So this is my initial value. My x and my t are just my x variables, or like your variables as we go, and t just is in reference to time. So these are our exponents, and in this case, all of the ones that we're worried about are in time. So exponent is equal to time. It could be years, it could be days, it could be minutes, whatever they tell you the time is, we're just going to use that as t. And that last piece that I skipped over, but I want to talk about now, is that b is the same thing as 1 plus r, and that is your growth or decay. The r is your rate. And so as we just talked about a minute ago, b is your growth and decay. And so we're going to do 1 plus the rate or 1 minus the rate, depending on what the rate is, and that will tell us our growth and decay. So even though these formulas look really different, they're basically telling us the same thing. Okay. Now we're going to use them in these problems, and we're just going to plug in to these equations. We're not going to solve anything. We're not going to do anything with it. We're just going to plug in the pieces into the next equations. Okay. So letter A says my initial value is 21. We're increasing at 21% per year. Okay. So I'm going to put that in my equation. This initial value is at P sub 0. And then I'm increasing at 21%. That's my rate. So we'll say P of T equals 21. Well, 21 seconds. And then 1 plus, when we make that 21% into a decimal, what is that? 0.21, good. And it says per year, so we'll raise it to the T. The only thing I can do to simplify this is just to combine what's inside that parentheses right here. And so I'm gonna do that. In the future, you can do that in your head before you write it down, but I just really wanted to like prove a point to you. So I'm gonna say P of T equals 21 times 1.21 raised to the T. That is my final answer here. Is everyone okay with that plugging and chugging that we're doing? Let's do the next one. Okay, this one says my initial value is 0.6 and we're decreasing by 3% per day. Now I know year and day are two different units of time, but we're just gonna keep it as T is time, okay? So when I write this, I'm gonna write P of T equals what? What's my initial value? 0.6, good. And then it says decreasing 3% each year. Am I gonna do 1 plus that 3% or 1 minus 3%? Minus. And how do I write 3% as a decimal? 0.03. And then it's gonna be raised to the T time. Again, the better at this you get, you'll do that 1 minus 0.03 in your head. But just because I'm being dramatic and proving a point, I want you to make sure that you do 1 minus it and you just don't put 0.03 in there. So P of T is equal to 0.6 times 0.97 raised to the T. Everyone's hanging with me so far? Okay. The next one, I'm adding a couple different elements here. It says the initial value is 6 and we're doubling every 3 days. When we say doubling, that's the same thing. Well, I guess you tell me. When I double 6, what do I get? 12. Good. So I had 6 and I'm adding another 6 to it to get 12, right? When I double 12, what do you get? 24, because you had 12 and you add 12 to it. So when you double, that's the same thing as increasing by 100%. When you double, you're increasing by 100%. You say, this is what I have. I'm going to take that exact same amount and combine it with what I have. Okay, so I only tell you that to help you think about how do we write that in this problem. So my initial value is 6. So we'll say P of T is equal to 6. And I'm not going to do 1 plus like 0.21 this time. I'm going to do 1 plus 100%. And what is the decimal version of 100%? 1. 1 plus 1. Now, what is 1 plus 1? 2. Now, sometimes you guys think it's easier to think of doubling as 6 times 2 raised to whatever power. So when you see doubling, you're like, oh, I'm just going to do 2 is going to be the base of my exponent. That is totally fine with me, but I just want you to know why it is like that. Okay. Now, the other funny part in this problem is every 3 days. Okay. It doesn't double every single day. It doesn't double every T. It takes 1, 2, 3 days and then it doubles. And it takes 4, 5, 6 days and then it doubles. And it takes 5, blah, 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 blah. Okay. To represent that, we're going to say it's T divided by 3. So however many times it takes to do that pattern, we'll say T divided by that number. So P of T equals 6 times 2 raised to T to the third, and I'll put that to the third in my initial step as well. T divided by 3. T divided by 3. Anytime, if it takes 50 days, we do T divided by 50 days. If it takes 120 days, we do T divided by 120. Okay. Now, let's take what we just talked about on the doubling and do that with my halving. Okay, so my initial value is 200. What do I get if I half 200? 100, right? You going a step ahead. We're getting rid of 50% every time, right? So when we are halving, I want you to think about we are decreasing by 50%. Now, this is a lot like the doubling. When I decrease by 50%, essentially we're doing 1 minus a half or 1 minus 0.5. I like fractions, so I'm going to do it as a fraction. 1 minus 1/2 just means that I'm going to have 1/2 inside my parentheses. So again, just like doubling goes to the 2 being in the parentheses, Halving is the same thing as just having 1/2, and you can write it as 0.5 if that makes you happy, or 1 divided by 2. Now we have to write our initial value, so that's my 200 equals P of T. We're just kind of working backwards this time. And it says it happens every 6 years, so how do I represent that? T divided by 6, good. So I showed you the shortcut for halving and doubling, but I also explained why that works. So you can think of it either way, but I don't want you just getting tripped over a shortcut, okay? Yep, so if we continue on, so I'm kind of at the point that we've already touched. We're gonna come down. 6, 7, 8, 9, 10 are all word problems. And actually, let's just do number 9 really quick, because I think that's literally all I have time for. So again, so far I'm flipping you around, but flip around, let's go find number 9. This is the exact same formula that I just taught you, okay? So this is the P sub T equals P sub 0 times 1 plus R raised to the T. And it says the 2000 population in Jacksonville, Florida was 700. No, that's not right. 736,000. Oh no, I was right. Sorry, numbers are hard this morning. And it was increasing at a rate of 1.49 each year. At that rate, when will the population be 1 million? Okay, so let's look at this. Let's plug in the pieces we have. What's my initial amount? Yeah, this number right here. So we'll say 736,000. And then we're gonna do 1 plus, what's my rate? At 1.49, right? So we're gonna make that a decimal. That's 0.0149. And I actually don't even have to do the plus. I can just tack it on to the end since I'm adding. This is kind of the step that I was doing out loud, but we can just do it in our head. When I add 1 plus 0.0149, I get 1.0149. And it's being raised to the T. Now it says, when will the population be 1 million? So 1 million, is that going to go in for my P of T, or is it going to go in for my T? My P of T, it's going to go in for my population. So I'm going to put 1 million over here. Okay. Tomorrow I'm going to teach you how to move exponentials into logarithms. And I'm sure you've seen that, but we haven't done that yet. So at this point, we would just graph these. I would graph this in your Y1 and I would graph that in your Y2. So as of right now, we're not doing any more simplifying and solving. All we're going to do is graph, and see where they intersect. Okay. We'll wait till tomorrow to finish graphing that, but we will do these word problems tomorrow, and then as much as we agree as I can get. Okay. Anybody have any questions right now? You guys technically have no homework.